Imagine looking into the depths of the universe, beyond the barrier of time. The universe, thought to be an endless expanse filled with distant stars and galaxies, holds mysteries that boggle the mind. But how can I tell you that in the dark, beyond the reach of our most powerful telescopes, lies something unexpected? The James Webb Space Telescope, a marvel of modern technology and science, is unlocking these mysteries and pushing the boundaries of what we know. But these revelations raise a dark, lingering question. What happened to these ancient and massive galaxies shortly after the Big Bang? What does this mean for our understanding of the world itself? As we explore these discoveries, prepare to change your understanding of the world. The dark age of the universe is when the moon begins to enter the universe. This period has been going on for years, until now. The James Webb Space Telescope has broken through this barrier, revealing massive, highly evolved objects that will challenge the foundations of our understanding. These are no ordinary galaxies. They are the universe breakers, superhuman beings who break the laws of physics as we know them. Consider galaxies like our own Milky Way that are 500 to 700 million years after the Big Bang. Results may vary. Previously, galaxies were thought to be relatively small, now relatively new entities that accumulate mass over billions of years. Yet here it is, fully formed and scattered throughout the world, as if time has sped up. These findings, published in the journal Nature, have caused a shock wave in the scientific community. Using infrared light, JWST can look back to when the universe was young, 13.5 billion years ago. This ability allows him to capture the brightness of ancient stars and galaxies and reveal their secrets to us. But the discovery of these massive galaxies is not the point. Scientists hope to learn more about the ancient world, but what they found shocked them. These changes are much larger than around 99% of the samples that show early galaxies. The prevailing theory is that galaxies began as small clouds of stars and dust and grew in size and complexity. But JWST's observations suggest that the early universe was much more noisy and productive than we thought. Data from JWST's first high-resolution images released in July 2022 revealed these massive galaxies as bright signals. At first, the researchers thought they were wrong. The galaxies appear to be very large and well-preserved for the time they were discovered. But when I received the information myself, it turned out that these were not false. They were true and wonderful. The team quickly realized that these galaxies were much larger than anything thought at the time. They were found immediately, as if they were waiting to be found. The discovery was like a wake-up call and forced scientists to rethink the entire history of galaxy formation. To better understand these galaxies, researchers use spectroscopy, a technique that breaks light into its wavelengths. This method allowed them to identify the elements in these galaxies and calculate the true distance. The results are amazing. Spectroscopy has confirmed that these are indeed galaxies, but doubts remain as to whether there could be something else, a supermassive black hole hiding behind it. The current stellar mass of the universe is 100 times greater than previously thought. Even if we assume that these galaxies are only half as old as the data suggests, the discovery is still shattering. Using JWST, an international team of astronomers confirmed the existence of the oldest and most distant galaxies ever discovered, dating back 400 million years after the Big Bang. At that time, the world was only 2% of its current age. The implications of these findings are profound. For decades, scientists have labored under the assumption that galaxy formation is a slow, natural process. These new findings are different. The world was able to build structures larger and more complex than we thought possible. This realization forces us to reevaluate everything we know about the world. How fast did these galaxies form? What were the factors that led to the rapid growth? And if these stars do exist, what else might be lurking in the corners of the universe waiting to be discovered? These questions don't have easy answers, but they guide the next part of the exploration. JWST's discoveries have opened a new chapter in our understanding of the universe, one that promises to be full of questions and answers. JWST isn't just about finding galaxies. Understanding the structure of life. By calculating the galaxy's redshift, astronomers can determine its distance from us. The universe is expanding, and as objects move away from us, their light shifts to longer, redder wavelengths, a phenomenon known as the Doppler effect. Redness measurement is very important to know the ages and distances of galaxies. Photographic methods, which use images taken from different filters, can provide an approximation, but accurate measurements require visual inspection. This method breaks down the light of an object into its wavelength components and further illuminates the characteristics of its properties. JWST observations focused on galaxies at redshifts greater than 10. Two of these galaxies, first discovered by the Hubble Space Telescope, have redshifts of 10.38 and 11.58 degrees. But JWST has found more distant galaxies, with redshifts of 13.20 and 12.63. These discoveries are changing the boundaries of what we know about the early universe. Redshift 13.2 was 13.5 billion years ago, 200 million years after the Big Bang. JWST's instruments, including the Near-Infrared Camera, NIRCam, and the Near-Infrared Spectrometer, NIR-SPEC, have played a major role in these discoveries. Created in collaboration with scientists from around the world, these instruments provide a unique insight into the past. The JWST Advanced Deep Extragalactic Survey, JADES, is one of the most ambitious projects ever undertaken by the telescope. Over a month-long investigation, JADES aims to provide a historical insight into the past. The project started in 2015, when the instrument groups came together to propose a comprehensive global survey. The JADES team, consisting of more than 80 astronomers and scientists from 10 different countries, focused on a small part of the sky called the Hubble Ultra Deep Field. This region has been studied by many large telescopes for more than 20 years, and nearly 100,000 distant galaxies have been discovered. But JWST has taken this exploration to a new level. By studying the field in 9 infrared wavelength bands, the JADES team has discovered a wealth of data. The light from 250 faint galaxies was captured over 3 days of observation using NIR-SPEC. These observations reveal the atmosphere and stellar properties of these galaxies, providing redshift measurements and a deeper understanding of their luminosity and stellar mass. With this data, scientists can describe the formation and evolution of galaxies over time. Just like following the development of a person from childhood to adulthood, understanding the beginning of the galaxy is very important to understand the subsequent development. JWST provides new insights into these formative years and sheds light on the processes that form the universe as we know it. As we continue to explore the universe with JWST, we are on the brink of a new planetary era. The telescope has answered some of the most important questions about the universe, but it also raises new questions. How fast did these early galaxies form? What role do supermassive black holes play in their evolution? And what other mysteries are waiting to be discovered in space? Looking ahead, the James Webb Space Telescope is expected to operate for at least 20 years, providing many opportunities for discovery. Its advanced capabilities allow scientists to delve deeper into the mysteries of the universe, from the formation of stars and planetary systems to the origins of black holes and the potential for life on Earth. Distant Exoplanets.in 2027. The Nancy Grace Rome Space Telescope is scheduled to join JWST in this global effort. These detectors provide a comprehensive view of the universe and help unravel the complex web of forces that shaped the universe over billions of years. But for now, JWST is our window to the first world. Discoveries change our understanding of the world and challenge long-held beliefs about the nature of reality itself. As we continue to explore the world with this amazing device, one thing is for sure, the journey has just begun. The James Webb Space Telescope, launched on December 25, 2021, is a milestone in our quest to understand the universe. Its main purpose is to extend and improve the capabilities of the Hubble Space Telescope by providing unprecedented information in the infrared spectrum. Unlike Hubble, which operates in light and ultraviolet wavelengths, JWST's infrared capabilities allow it to see through dust and atmosphere, revealing hidden structures of galaxies, nebulae, and star-forming regions. With a primary mirror 6.5 meters in diameter, JWST is the largest and most powerful space telescope ever built, capable of detecting faint signals from the farthest reaches of the universe. One of JWST's greatest achievements is its ability to capture light from the earliest galaxies that formed a few 100 million years after the Big Bang. By studying these ancient constellations, astronomers hope to discover the processes that led to the formation of stars, planets, and the fate of life itself. But JWST isn't just looking back. It is also a tool for exploring the contemporary world. Its advanced instruments can analyze the atmospheres of exoplanets, search for signs of habitation, and detect potential biosignatures, signs of extraterrestrial life. As we enter a new era in the universe, JWST is poised to answer some of the most profound questions about our place in the universe. But new questions may arise that challenge our understanding of the world and push the boundaries of human knowledge. The discoveries made by the James Webb Space Telescope are just the beginning of a new chapter in our exploration of the universe. As we continue to push the boundaries of what is possible, we remember that the world is vast, mysterious, and wonderful. With each new observation, we uncover the mysteries of the universe in bits and pieces. Universe breakers, the giant galaxies that defy our understanding, are just one example of the many wonders waiting to be discovered. Looking to the future, we can only imagine what other discoveries JWST will bring. Will we get more universe breakers? Can we find the origin of life? Or will we discover something unexpected that will change our understanding of the world forever? One thing is certain, the James Webb Space Telescope has opened a new window on the world, and the view is amazing.